welcome to lesson 10.1, day 3. Today we are going to talk about circumference and arc length. The circumference of a circle is the distance around a circle. It is essentially the fancy word for the perimeter of a circle. And when we find the circumference similar to perimeter, we are using units, not squared, right? Not squared, not cubed, any of that. It's just in units. Similar to how we would say just like the perimeter is 32 feet. It would be 32 feet still within our circumference. Now, the formula for the circumference can be found using two things. First, we could use 2 times pi times the radius, or we could use pi times the diameter. Why are there two different formulas? Well, remember, 2 times your radius equals your diameter. So you can make that substitution in for 2 times pi, because again, 2 times the radius will equal your diameter, and we're just making that substitution. So oftentimes, based on what you are given, is which formula you will want to use. So if you look down below, we want to find both the exact and rounded answers for each of the following. So we want the circumference given a diameter of 6 inches. So our more useful formula to us is going to be pi times diameter, because that's what we were initially given. So we would say pi times 6, which if we were looking for the exact answer is 6 pi. Or we are going to round using the pi button on our calculator. 6 times pi is about 18.8. And again, these are going to would both be measured in just inches, since it is the circumference. And the second one, we are given the radius is 5 feet. So our more useful formula this time is 2 times pi times that radius value. So 2 times pi times 5, 2 times 5 is 10 pi if we are looking for the exact answer, where we leave the pi. Or if we're going to round, we're going to take 10 times pi in our calculator, or we could type that in even as 2 times pi times that radius value of 5. Either way, we're getting 31.4. Okay, for our approximated answer. The next one is asking us to work backwards. They are telling us the circumference is 19 feet and we want to find the diameter. So again, when we're involving diameter, pi times diameter equals our circumference. This time they're giving us the circumference is 19 pi, and we want to work backwards to find what our diameter value is. So we can divide both sides by pi, and we notice that they cancel, and our diameter is just left to be 19. On the last one, they are giving us, again, the circumference, but this time asking us for the radius. So again, this time it's going to be more useful to us to use 2 times pi times that radius, plug in for the circumference this time, the 22 pi, and we can then divide away again the pi from both sides, so that cancels. We have 22 equals 2 times r, divide both sides by 2, our radius is 11 this time. We have 2 examples down below for you to try. This first one, you are finding the circumference, just round to the nearest tenth. On the second one, you are working backwards. You are given the circumference is 20 pi. Find the radius. Now, arc length is going to be a portion of your diameter, or excuse me, of your circumference. So this is still a distance, but it's the distance between the endpoints of your arc. So I like to think about it as like the length of the crust of your pizza. Okay, it's a fraction of that overall circumference. Okay, and when we look for arc length, we use the variable s, and essentially what ends up happening, it is the central angle measure, so these degrees, divided by 360, because that's how we're going to get the fractional value, and then we're going to multiply it by 2 pi r. So again, when we're looking for this, what is n? The n is going to be your central angle measure in degrees. So again, n degrees is the measure of your central angle. So down below, we see a couple examples for us to try. The first one is asking us for the length of this arc shown A to B. So again, we're going to use the central angle measure, which is the same as the arc degree, right? These are both going to be 24. We're going to divide that by 360, and then we multiply it by 2 times pi times that radius value. Again, they gave us the radius is 5 on this one. So when we type this in the calculator, you're going to do 24 divided by 360 times 2 times pi times your radius value. We're going to round to the nearest tenth, it says this time in the instructions, nearest tenth. So 2.1, officially centimeters, since that was given the units for that one. On the second one, notice they actually start by giving us the diameter length is 9. So our radius is going to be half of that, 4.5. The central angle measure this time is 56 degrees. So 56 times 360 times 2 times pi times that radius. So this time we type it in 56 divided by 360 times 2 times pi times your radius. This time we get about 4.4 centimeters as our final answer. Now, you may be saying, could I have just used the diameter and used pi times diameter? You officially could have. We could have done 56 divided by 360 and times pi times our diameter, and we still would get that same answer, right? But we want to get in the habit for when we talk about arc length or area of a sector tomorrow, where we have to use the radius. That's why we usually use radius. All right, the last one does not give us a picture, but it does tell us we are looking for the length of an arc, given the measure of the angle 17.2 and the diameter is 14 inches. So again, they gave us the diameter. Radius then is half of that, so 7. So when we're looking for that arc length, angle divided by 360 times 2 times pi times that radius ends up being a value of 8.8 inches. All right, 2 final examples for you to try on this first one. They are giving you your radius, and you are finding the length of this major arc this time, round to the nearest tenth. And on the last one, they are giving you the diameter and your central angle. You are looking for the length of that arc. Thanks everyone for watching. We'll work more with these in class.